Okay, pay attention to this one. The diagrams show a circular sector of radius 10, angle theta, which is formed into a cone of slant height 10. So that's the radius, is the slant height. The vertical height h of the cone is equal to the radius of its base. So we have that this is this. Okay, so that means find the value of r. So we're going to have x squared plus x squared equals 10 squared. So 2x squared equals 10 squared. So x squared is 50. So x is root 50 or 5 root 2, which makes sense because this is a special right triangle. Find the angle theta in radians. So if we have that x is 5 root 2, this circumference here, so 2 pi r, is going to be this. Okay, so 10 pi root 2 is that arc length, which is equal, the arc length is 10 theta. So theta is going to be pi root 2. All right, 25 diagram shows a triangle and two arcs of circles. The triangle ABC is a right angled isosceles triangle. So that's 45 and that's 45. The point P is the midpoint. The arc BDC is part of a circle with center A. And the arc, so this has circle P. All right, calculate the area of that shape, BDCP. So we want this bit, okay? So we want, this is just the area of a sector. So we're going to have, well, the area of a segment. So we have the area of the sector, this whole thing here. So that's going to be 1/2 r squared theta, which is 90 degrees, or pi over 2. So actually this is just going to be pi. And from that we're going to subtract, which makes sense because we have a quarter of a whole circle. And the whole circle would be pi r squared, 4 pi. So we'd want 1/4 of that. Anyways, that's side note. All right, so the area of that quarter circle is pi. And then from that we subtract the area of the triangle, which is 1/2 A, B, 2, sine pi over 2. Pi over 2 is up here, that's 1. So we're just going to have half of 2 cancels. 2, this is 1. So pi minus 2 is the answer to A. For B, calculate the area of the shaded region. So we're going to have, okay, so first of all, we'll do 2 squared plus 2 squared equals BC squared. So that's 4, 8. So we have that BC is 2 root 2, right? So that means this is root 2 and this is root 2, the radius of this half circle. So we need the area of a half circle. So 1/2 pi r squared. And we're going to subtract the area of this bit, which we just found out to be pi minus 2. Subtract that whole thing. Okay, so this is going to be 2 over 2, so that cancels. Pi minus pi also cancels, so we're just going to have 2. Okay, so this is a classic kind of problem. We got a pair of intersecting circles. P and Q are the centers, radii 5 and 6. RS is the common chord, and PQ is 7. Okay, so find the area of the shaded region. So if you look, this, we're going to find this area of a sector, and we're going to subtract this triangle. And that will give us this area, okay? And then on the other side, we're going to do the same thing. We're going to find the sector, subtract the triangle, and we'll be given that. We'll just add those two together. Okay? So, area, all right, so yeah, we have to find this angle using cosine rule. So we're going to have cosine C equals 5 squared plus 7 squared minus 6 squared over 2 times 5 times 7. So C ends up being 57.1. So we need to multiply that by 2. Which is 114.243. And now we can find the area. Oh, okay. Should have done this in radians. Hold on. So instead, we have this whole angle. I just went ahead and did the whole angle. It's 1.99392. Okay, so now we've got the area of the sector, which is 1/2 r squared theta, minus the area of the triangle, which is 1/2 AB, which is the same sine 1.99 dot dot dot. This gives the area of this bit here, which is going to be 13.5264. Okay? Now, with the other triangle, this, we have that cosine C equals 6 squared plus 7 squared minus 5 squared over 2 times 6 times 7. All right, so one of those angles is 0.775. So this whole thing is 1.55039. And now we can do the area of the sector, 1/2 r squared theta minus the area of the triangle. So this ends up giving you 9.910 dot dot dot. And when you add this and this together, you get 23.4 centimeters squared. Okay, 27, 2 discs, 1 radius 8, 1 radius 5. They touch each other. A piece of string is wrapped around both discs. So that's this thing on the outside. This is shown. Calculate the length of the string needed to go around the discs. So we need this bit. We need this bit. And then we need these lengths here. Oops. And red. Okay, so if I draw a right triangle here, if that's 13, that's 8, that's 5, this has to be 3. So I can find that length there with Pythagoras. So we've got x squared plus 3 squared is 13 squared. So 169 minus 9. So we've got x is root 160 or 4 root 10. So that's this length here. Okay, so we can do the same thing here. We would find out, it would be the same. This would also be 3. That hypotenuse would also be 13, and yeah, we'd find this to be 4 root 10, which is that thing. So we have this in red. Both red bits are 4 root 10. Okay, so now we have that this is a right angle, this is a right angle. We need to find one of those angles, and we can use opposite over hypotenuse. So sine of the angle is 3 over 13. And what we'll do, 3 over 13, we need, so theta is 0.232868. So that's just one. So we need both of these. So multiply that by 2. And so let me write these as radians. This is pi over 2. This is pi over 2. This is, like the whole thing, that whole blue thing, is 0.465, blah, blah, blah. So we can now find out this, because we can do 2 pi, one whole circle, minus pi over 2 minus pi over 2, which is obviously pi, and then minus that 0.465. Okay, so that means that this angle is 2.675, blah, blah, blah. Okay, so now we can find the length of that arc, and it's going to be r theta. So when we do that, this is 13.4 to 3 significant figures. Maybe I should do just 379, whatever. Okay, same thing on the other side. We have, this is pi over 2 here. This is pi over 2. And we need this whole angle. So we'll start by finding just one of those angles. And that we can use adjacent over hypotenuse, so cosine 3 over 13. And then multiply that by 2. So this whole angle here is also the 2.67. And, oh, actually we don't even care about this pi over 2 or this pi over 2. This whole thing here is just the 2.67. So we can do 2 pi minus that to get this whole thing, which is 3.60 ... So that length of the arc is 8 times 3.60 ... And that is 28.8586. So now we need to add this, and both of those. So that plus the 13 plus 2 4√10s, which gives 67.5 centimeters. A circular disc is cut into 12 sectors, so yeah, whose areas are in an arithmetic sequence. Explain why the angles of the sectors are also in arithmetic sequence. So we have a picture, it's going to be like this one is some angle, and then this one is like a bit more, you've added a bit more, and then this one you've added a bit more, and you know, something like this, okay? So our thetas are changing, okay? Something like that, blah, blah, blah. Okay, so if we have the areas in arithmetic, so we have 1/2 r squared theta. We'll just say 1. And then we'll have 1/2 r squared theta 2. And then we'll have 1/2 r squared theta 3, and then all the way up to 1/2 r squared theta 12. So we know the difference between these are the same. So 1/2 r squared theta 2 minus 1/2 r squared theta 1 is going to be equal to 1/2 r squared theta 3 minus 1/2 r squared theta 2. All of these 1/2s and r squareds can go away. We can factor them out. So theta 2 minus theta 1 is equal to theta 3 minus theta 2. So the differences are the same. So for B, the angle of the largest sector is twice the angle of the small sector. Find the size of the angle of the smallest sector. Okay, so we have 1/2 r squared theta 1. And this, so twice that angle is going to be equal, I don't think we can write it like that. So twice theta 1 is going to be equal to theta 12. So you're not going to be able to use the nth term at all because you don't know the difference between the two. And that would give you two variables to solve for, and you can't do that. So you have to use the sum. You have to use the sum because that's the only other thing you have. Now, you know the sum of all of these angles is going to add to 2 pi because, it makes up a whole circle. And then, so if you have the sum of 12 angles, and that is equal to 2 pi, and that is n over 2, and we can't use that one that contains d because we don't know the difference, but we can use the first and the last, okay? So we can use that theta 1 is 1/2 theta 12, and we can use that theta 12 is theta 12, okay? So it's u1 plus the 12, the first term plus last term, that's what, because we know these are in arithmetic sequence as well, okay? So if we multiply by 2, that's 4 pi over 12, and that equals 3 over 2 theta 12. So if we multiply by 2 and divide by 3, so 36 is theta 12. Can simplify this down. 4 goes into that twice and 9 times. So if that's theta 12, 2 theta 1 is 2 pi over 9. So we're going to have that theta is pi over 9. Theta 1. All right, 29. The diagram shows sector AOB of a circle of radius 1. So this whole thing is 1. Center O or AOB is theta. Lines AB, all that, are perpendicular to OB. AB1, A1, B1 are all arcs of circles with center O. Calculate in terms of theta the sum to infinity of the arc lengths. Okay, so let's get some of these arc lengths so we know what we're doing here. So AB here, that's radius 1. Okay, so the arc length is going to be R1 theta theta. Okay, that's arc length 1. Now, if we do A1 B1, this is not arc length. It's not radius 1. So we need to find like this radius, which is this radius. Okay, so actually if we do this radius in terms of theta, because this is 1, all right? So if we look at this triangle, that radius here, this is the adjacent, and this is the hypotenuse 1. So we're going to have that radius is going to be cosine theta. Okay? Because cosine theta equals the adjacent over 1. So A, the radius, is cosine theta times theta. Okay, r theta. Okay, so now if we do the next one, we need this length. All right. So that means we need this. So if you look, because we know this thing, this was cosine theta, that whole thing. We need this new radius, which is from here to here. And we know the hypotenuse in terms of theta. So this distance, if we want to find that out, that is going to be the adjacent, because this is the right angle. So that's the adjacent, and this is the hypotenuse. So we're going to have cosine again. Cosine theta equals the adjacent, what we're looking for, over the hypotenuse cosine theta. So the radius of this thing, this is A, is going to be cosine squared. That's r, and theta again is theta. All right. So I think you can see, if we did like one more thing, if we want this one, we just found out that this one was cosine squared theta. So if we want this, we're going to have cosine theta is the adjacent over the hypotenuse. So A is cosine cubed. That's our new radius. And that's times theta. And dot, dot, dot. Okay. So calculate in terms the sum to infinity. So if we need the sum to infinity, this is geometric, where u1 is theta and r is cosine theta, because we're multiplying by cosine every time. For b, given that the sum to infinity of the arc lengths is 2 pi over 3, find the value of theta. This is going to be with the graphing calculator. So you can either graph it or end solve it. And I did the same thing as last time, because when you put this in, you get theta 0, but clearly theta can't be 0. So I get theta is 1.05. When I put this in and solve this, comma theta, I actually used x, whatever, and then I put like this.